This lecture covers Math Review that begins on page 3 of your manual. Your instructor is Cindy Davis. Cindy has a master's degree in math education and has been teaching for over 18 years. You will be reviewing units of measurement, geometry area, and volume formulas, and how to use an architectural scale. This information will prepare you for math and estimating questions presented on the state exam. Please turn to page 3.
Hi, welcome. So if you'll turn to page 3 in your book, that's where we're going to start. It's very important that as you're taking this test, that when you read numbers, that you're reading them very carefully. So for instance, decimal 1.5 feet is not the same thing as 1 foot 5 inches, because 1.5 feet would indicate a foot and a half of a foot. A half of a foot is 6 inches because there's 12 inches in a foot. So it's very important that as you're reading through the test that you're reading very carefully. And for instance, if you see 1 foot dash 6 inches, that you're not interpreting that as being 1.6 feet, because 1.6 feet is actually more than 6 inches. So we have a list in the book of different decimal and fraction equivalents. You don't need to memorize this table because you could figure it out from scratch. For instance, if you have 6 inches, as we just talked about, that's 6 out of 12. 6 inches out of 12 inches is indicating how much of a foot those inches are. So you could do 6 divided by 12 in the calculator that you're allowed to use, and that'll give you 0.5. If you were actually looking to change 7 inches to how many feet, you could just take the 7, divide it by 12, because there's 12 inches in a foot. It would give you the decimal equivalent of about 0.583. So that's closer to actually being 0.6. Again, very important that when you're reading through the test and you see something like 1.5 feet, that you stop to think, okay, well, that's actually a whole foot and a half of a foot, and the half of a foot being 6 inches. If you look down the next list, there's different units of measurement. Again, not all of these you have to memorize. You should know that a yard is 3 feet, and each foot is 12 inches. Therefore, if you kind of take that and put it together, each of those 3 feet would contain 12 inches. So therefore, there's 36 inches in 1 yard. Looking over to the right at area and volume, we measure area very naturally in squares. As you know, if you're going to tile a floor, you're going to cover that floor in squares. And that's how we cover just about anything in mathematics too. We think about squares, square feet, square inches, square yards. So if we were to take a 1 foot square, that would be a 12-inch square by a 12-inch square, making 144 square inches. If you were going to take a 1 square yard, that would be a 3 foot square by a 3 foot square. That makes 9 square feet. Whereas volume is measured in cubes. If you think about filling up a glass or a room, and you think about filling it up with ice cubes, it's pretty easy to remember that what we're actually measuring volume with is cubic units. So for instance, if we had to take 1 cubic foot, that's 12 inches by 12 inches by 12 inches. So if you multiply 12 times 12 times 12, that's where that 1,728 cubic inches comes from. So again, not something you have to memorize if you have your calculator handy and you know that 12 inches makes a foot. 1 cubic yard would be 3 feet by 3 feet by 3 feet, making 27 cubic feet. There are actually different ways of abbreviating square feet. The most common that you'll see is the SQ-FT, indicating that you're measuring what you're measuring in 1 foot by 1 foot squares. But you might also see the abbreviation FT with a little 2 to the right and above it. You might remember that as an exponent from your math classes from high school, but that indicates feet to what we say is the second power. It's just a small 2 up and to the right. That's another way of abbreviating it, and it doesn't mean that you're supposed to do any more math involved. It just means that it's a simple way of describing it's a foot by a foot. In the same vein, you could have inches with a tiny little 3 up and to the right of it. That indicates that they're talking about a 1 inch by 1 inch by 1 inch. They're talking about a cube, a 1 inch cube. So think about that as a little ice cube that is 1 inch by 1 inch by 1 inch. Okay, if you turn your attention to the bottom of page 3, we're going to go over some standard geometry formulas. Geometry formulas that you'll probably use all the time. For instance, if you need to define the area of a rectangle, say you were looking for how much paint to paint a wall or how much tile you need to cover a floor, then you're going to need to calculate the area of a rectangle. The standard formula is the base of the rectangle times the height of the rectangle. You might have also remembered this from middle school as the length of the rectangle times the width of the rectangle. Either one can be commonly used, and basically what you're doing is taking one side of the rectangle and multiplying it by the other side of the rectangle to figure out how many squares to cover your area in. So for instance, let's say we have a 6 foot by 4 foot rectangle. We're going to take the 6 feet and multiply it by the 4 feet. 6 times 4, 24, and then what we're covering it in then is square feet. So your answer would be 24 square feet. All right, turning to page 4. If you look at the top of page 4, you'll see the area of a square. Now, a square is just a special sort of rectangle where the two sides are exactly the same length. So instead of talking about a base and a height, we talk about the side of the square, and we usually abbreviate that with an S. Since we're multiplying the side times the base times the height, you might see the formula of side squared, which just indicates you're multiplying the side by itself. So for instance, if you're measuring an area of a square that happens to have a side length of 4 feet, what you would have is a base of 4 feet, a height of 4 feet. You would have 4 times 4, or 4 times itself. That would be 16. And then of course you're measuring it in square feet. In the bottom half of page 4, we're going to move on to examining triangles. Most of the triangles that you will see on your state exam are going to be right triangles. Those are usually indicated with a little square in the bottom corner of your triangle, either on the right or on the left. That indicates a right angle, a 90-degree angle. Now, since a triangle really can be thought of as half of a rectangle, really you're going to use the same formula. You're going to talk about the base times the height. However, because the triangle is only half of a rectangle, you're going to take half of that base times height. Or take your base times your height and divide by 2. For instance, if you had a right triangle with a base of 6 and a height of 4, similar to our rectangle from before, we would take the 6 feet by the 4 feet, multiply them, but because it's only half of the rectangle, we're going to actually take that 6 feet by 4 feet and divide by 2. When we have the 24 square feet and we divide it by 2, we end up with 12 square feet. So if you draw your attention to the second problem under topic number 3 on page 4, there might be a time that on the exam they don't ask you to find the area of the triangle, but they might ask you to find one of the side lengths of the triangle. You can do this as long as you have 2 other side lengths on a right triangle. This can only be done on right triangles, so make sure that you identify what your right triangle is before you begin. Now, there's a very famous theorem called the Pythagorean theorem, and you may have heard of it. Usually, most high school teachers teach this as a squared plus b squared equals c squared. But in order to use the formula, you'll have to know what a, b, and c indicate. In a right triangle, there's 3 sides. The right angle will point to what we call the hypotenuse. That hypotenuse has to be part C. It is the longest length on a right triangle. The other 2 lengths, the ones attached to the right angle, we call those legs. So another way to think of the Pythagorean theorem is to say that you take one leg and square it, the other leg and square it, and if you add those 2 together, it'll equal your hypotenuse squared. Keeping in mind that squaring a number simply means to multiply it by itself. So let's say we have a right triangle, and I tell you that one leg, or A, is 4 feet, and another leg is 6 feet. We're going to use the Pythagorean theorem to find out how long our hypotenuse is. So what we would do is just plug it into our formula. So we're going to do 4, and we're going to square it. And then we're going to add it to 6 squared. On the other side, we still have the hypotenuse squared, which we're just going to leave it as c squared. Now 4 squared is just 4 times 4, and that would be 16. 6 squared is just going to be 6 times 6. That's 36. Again, it's still equal to our hypotenuse squared, and since we don't know what that is, we'll keep using c. If I take the 16 and 36 and I add them together, I should get 52 equals c squared. So in order to identify what our hypotenuse is, we would need to know what squared is 52. Continuing from page 4 to page 5, the top of the page, well, we know 7 squared is 49, and that gets us pretty close. But to get an exact answer, you would need to use your calculator. Now, most calculators have a button called a square root button. It looks kind of like a check mark with a hat on top. What you would do is, on most calculators, is plug in 52 and then hit your square root button. And it should give you the answer of 7.21. There are a few calculators out there where you have to hit the square root button first, and then the 52, and then hit the equal sign, in which case that should also give you the 7.21. So it's very important that before you go into your test, that you're familiar with the calculator that you're planning on bringing into the test. Now, there are some right triangles that show up very frequently on most of these tests. And this particular right triangle you use to, say, square up a building. And that's called a 3, 4, 5 right triangle. This is true because 3 squared plus 4 squared is equal to 5 squared. 3 squared being 9, 4 squared being 16, adds up to be 25, which is the square of 5. Now this 3, 4, 5 can show up on your test in multitudes of ways. For instance, if you take a 3, 4, 5 and you double the size, you'll get a 6, 8, 10 triangle. Or if you take a 3, 4, 5 triangle and you multiply it by 10, you'll get a 30, 40, 50 right triangle. And you can use these measurements frequently to kind of skip over a lot of the math that you might be asked to do. But just be careful that you actually have a 3, 4, 5. Now, on page 5, section 4, we're going to talk about trapezoids. Trapezoids are a little bit like rectangles, although the top base and the bottom base are different lengths, so they're kind of dented in. They work very similarly to rectangles, but unfortunately, because there's 2 different size bases, you have to do what we call averaging the bases, which means we take the top base and the bottom base, we add them together and divide by how many numbers there are, 2. So we're going to take the top base and the bottom base, add them together, divide by 2, and once we have that number, then we're going to multiply by the height. For instance, the example problem in the book, if you have a top base of 4 feet, a bottom base of 6 feet, then what you would do is take the top base, 4 feet, and the bottom base, 6 feet. Add them together, giving you 10 feet, and then divide by 2 because we want to take the average of it. So the average of that would be 5. We're going to take that 5 feet, on average that's our base, and multiply it to the 4 foot. That'll give us 20 square feet. All right, section number 5 talks about circles. There's several things you need to know about a circle before we can begin. For instance, the measurement from the center of the circle to anywhere on the outside of the circle is called a radius. All those radiuses have to be equal, otherwise you won't have much of a circle. Now, if you go all the way through the center of the circle, all the way to the other side, that would be called a diameter. You can see that in the picture to the right. In order to measure the outside of a circle, normally we call that the perimeter, but on a circle it has a special name. It's called the circumference. It should be noted Any circle in the whole wide world, if you take the circumference and divide it by its diameter, it will equal this random number that we lovingly call pi. Pi is approximately about 3.14, but it kind of goes on and rambles on. So we use 3.14 because that's a really good approximation for pi. So if I wanted to find the circumference of a circle, I could just take my diameter and multiply it by pi. And that's the main formula that I would like you to commit to memory. Now, on the exam, you might also see that the circumference of a circle is 2 times pi times r. But if you keep in mind that 2r, or 2 radiuses, is a diameter, that should give you some light as to why 2 pi r is the same as pi times the diameter. For instance, if you had a circle that had a diameter of 24 feet, well, to find the circumference or the length around it, all you would do is take your 24 and multiply it by that special number pi. 24 times approximately 3.14. Take your calculator out, hit 24 times 3.14, and it gives you 75.36. Since we're only measuring a length around, it's still in feet. Problem number 2, if they give you the radius instead of the diameter, you can use your 2 pi r formula, in which case you would take 2 times pi times the radius, being 12 feet. So you could hit 2 times 3.14 times 12 and get the answer of 75.36 feet. If you turn to page 6 at the top of the page, still talking about circles, but instead of talking about finding the length around the circle, we're going to talk about how to find the area of the circle. In other words, how many squares about would cover up the circle. There's this very standard formula, which you probably remember from high school, which is that the area of a circle is pi r squared. Now, sometimes they'll give you the diameter of the circle, and you can use a different formula. That would be that pi times your diameter squared, and then divide it by 4, because each radius would be diameter divided by 2, diameter divided by 2. That's where you're dividing by 4. Now, problem number 3. If you're given the diameter of 24 feet, you can use the second formula. The second formula being pi times your diameter squared divided by 4. What you would do is take pi, multiply it by 24 squared, and then divide by 4. So in your calculator, what you're actually going to punch in is 3.14 times 24 times another 24. And then you're going to take that and divide by 4. It should give you 452.16 square feet. It's important to notice that we're squaring the diameter, but we're not squaring pi. So the diameter is the only thing that gets multiplied by itself. In problem 4, we have a radius of 12 feet, which is the same as having a diameter of 24 feet. You can then use the more famous formula, pi times your radius squared, which you would take pi and multiply it by 12 squared. 12 squared being 12 times 12. So in actuality, you're going to take pi, approximately 3.14, multiply it by 12, and then multiply it by 12 again, giving you 452.16 square feet. At the bottom of the page, we'll start into volume. Now, volume is about how many cubes will fill something up. So let's talk about the first volume formula that you see on the page, which is an actual cube. A cube is called that because all 3 sides, all 3 dimensions, are exactly the same length. It's kind of like a square in 3 dimensions. So we only have one letter, which is S. In order to find the volume of it, we do S times S, and then multiply it by S. That gives it that 3rd dimension. For instance, if I had a cube and the side length was 4 feet, then I would do 4 feet times 4 feet and multiply it by another 4 feet. 4 feet times 4 feet would give you 16 feet. Multiply it by another 4 feet. It should give you 64 Now we're in cubic feet. How many 1 foot by 1 foot by 1 foot cubes will fill up that box? Now, if you look at the top of page 7 in your manual, example 2 talks about a rectangular prism, kind of like a cereal box, or a room. In order to find the volume of the room, you're going to take the area of the floor, multiply it by the third dimension, which would be the height of the room. So for instance, if you're looking at your diagram in the book, you would take the base of the room times the depth of the room. Then you would take that area and multiply it by the height of the room. For instance, in the problem, we have a 12 foot by 16 foot room, and it has a 10 foot ceiling. So we're going to take the 12 foot by 16 foot and multiply that, and then multiply that also by the height, being 10 feet. It gives you a total of 1,920 cubic feet, because again, we're talking about how many cubes will fit in the room. It should be noted also that when you're multiplying 3 numbers, you can multiply them in any order you choose, but because you have a calculator, probably best just to multiply them in the order that you would put them in. All right, if you're trying to find the volume of a cylinder, now a cylinder is shaped like a can or a piece of pipe. If you're trying to find the volume of a cylinder, you're going to approach it the same way. You're going to find the area of the base. Remember our famous formula, pi r squared, and then we're going to multiply it by its height to give it that third dimension. For instance, as in our problem, our sample problem, we're trying to find the volume of a 6-inch pipe that is 1 foot long. Now there's all sorts of places that you could get trapped in here. Number 1, they're giving you the diameter of the pipe. They are not giving you the radius of the pipe. And when we're trying to find the area of our base, we really want to use pi r squared. The second issue is the height of our pipe, or the length of our pipe, is given in feet. And we really need to change everything to being in the same units. So when we're going into our formula, we need to be very, very careful. Our radius is only halfway across the circle. All the way across the circle is 6 inches long. Halfway across our circle would be 3 inches long. Now, the height of our pipe is given by 1 foot long. Now, since we're using inches for our radius, we really need to use inches for our length as well. We're actually going to multiply it by 12 inches. So we're going to take 3.14 for pi. We're going to multiply it by 3, and then multiply it by 3 again. Then we're going to multiply it by 12 for the height or the length of the pipe. Should give us approximately 339 cubic inches. That's rounded. Now, if you draw your attention to the bottom of page 7, we're going to talk about architectural scale. If you're being asked to take a set of architect's plans and to figure out, say, how long a wall is, how long some pipe is, you're going to have to understand the scale that they're using. So, first of all, very important to go through the plan, find the key, and figure out what scale they're using. Once you determine your scale on your plans, then you have to go to your architectural scale and figure out which side to use. Now, since one side is just regular old inches, that's probably not the side that you're going to use. But for instance, let's say your scale was in 3/8 inch, you want to find the 3/8 inch side. Now, if you're going with the 3/8 inch side, it's written on the right of one of the sides of your architectural scale. Since it's on the right-hand side, going from 0, that's our starting place, and moving to the left, we're going to use the top numbers. If you were using 3/4 of an inch scale, you go from the left-hand side toward the right-hand side. So you would start at the 0, 1, 2, 3, 4, and that way each mark in between would then indicate a half of a foot. So it's important that you first determine the scale on the drawing, and then you find that scale on your architectural scale in order to measure. Now, if you'll turn your attention to the top of page 8, we have 3 examples up at the top of different rulers. The very top ruler is just a regular old ruler. notice that we show you how much 1 1/4 inches. You'll notice that a regular ruler is broken up in 16ths. That's typically how we measure inches. However, an architectural ruler is different. Because each major portion is indicating 1 linear foot, the smaller portions need to indicate part of a foot. Now, how do we break up feet? We break up feet in 12 inches. So most of the indicators of the smaller pieces will be broken up in 12ths, sometimes 24ths if we want to look at a 1/2 of an inch. On the second diagram down of the ruler, notice on the right. On the very far right, you'll notice 1/2 with an asterisk next to it. That 1/2 tells us that actually what we're measuring in is 1/2 inch scale. That means every single 1/2 inch is indicating 1 whole linear foot. So if I wanted to measure out 1 whole linear foot and 3 inches, I would need to go from the 0 to the 1. That's going from the right to the left. So we start at 0, go over to 1. That is 1 whole linear foot. Indicate 3 inches, we go to the right of the 0 to indicate we just need 3 more small pieces. 1, 2, 3. And if it's 3 out of 12, that would indicate 3 inches. Over on the left of the same exact ruler, it is a 1-inch scale. Now, because it is a 1-inch scale, we can actually measure more precisely. If we go from the left to the right, we go from the 0 to the 1. That's 1 whole linear foot. To the left of the 0, we go to where the 3 is indicated. That is 3 inches. If you'll notice, there's more slash marks in between the 0 and 3. And therefore, these are actually broken up in 1/2 inches. So you can measure more precisely if you need to. But all we're going to measure is 1 foot, 3 inches. Going down to the third ruler. If you're looking at the right-hand side, we're talking about measuring in 3/8 inches. That means that every 3/8 of an inch is going to indicate 1 linear foot. So again, we start at the 0, go to the 1, and that's 1 linear foot. If you go 3 smaller marks to the right, that's your 3 inches. The 3/4 inch scale is on the left-hand side. If we're using the 3/4 inch scale, we're moving from the left to the right-hand side again. So we would go from 0 to 1. Notice that the 28 is actually part of the 3/8 scale. So that was going from the right back toward the left. We want 3 more inches in that. So we want to move 3 inches to the left. Notice that because the scale is larger, they actually show you every 1/2 inch. So we actually are going to go 1, 2, 3 of these medium tabs in, instead of using the smaller tabs. If you draw your attention to sample problem number 1, which is halfway through the page on page 8, we're using a scale of a 1/2 inch. Each 1/2 inch is equaling 1 linear foot, and they want us to figure out how much is represented by the line below. Well, as you can see, there's already a ruler there. Now, remember with the 1/2 inch, since it's on the right-hand side, going from 0, that's our starting place. And moving to the left, we're going to use the smaller numbers. So the very first hash mark would be 1 linear foot. The next hash mark would be 2 linear feet. And the third hash mark would be 3 linear feet. Notice that in order to mark inches, we bring the ruler back a little bit so we can figure out how many inches we have. Now this one on the right-hand side is broken up. 1 hash mark equals an inch. We have from 0 to 6 inches. Going from 0 to the right, it's 0 to 6 inches. And then we have 1, 2, 3 more inches than that. So it actually should be 3 linear feet and 9 inches. Using your architectural scale on sample 1, you want to take your ruler and line it up. Make sure that you're on your 1/2 inch scale. line up your 0 with the right endpoint. Then you'll notice that your line almost extends to 4 linear feet, which makes sense because our answer is almost 4 linear feet. Because it's not actually 4 linear feet, we're going to want to pull our ruler to the left, lining up the third hash mark with the left endpoint. Then you would be able to see that you have 3 linear feet. 1, 2, 3, going to the left of 0. Going to the right of 0, you can measure your inches, which would be 9 hash marks in. Again, you have 3 feet, 9 inches. In example 2, we're using a 3/8 scale, which means every 3/8 of an inch, you'll have 1 linear foot. Now, looking at the ruler that is already below it, if you start at the 0 line and move to the left, that is 1, 2, 3, 4 linear feet. Notice that you are not using the numbers below, you're using the numbers above, which you could probably notice because those are the numbers increasing from 0 to 4. Now, to the right, we have part of a foot, not quite an entire foot, but pretty darn close. You have 11 hash marks to the right, and that is 11 inches. So what we have here is 4 linear feet and 11 inches. So your answer would be 4 feet dash 11 inches. Using your architectural scale, you would take the 0 and line it up with your right endpoint. Then you'll notice as you measure it, it almost makes 1, 2, 3, 4, 5 linear feet, but not quite. So you want to pull it back so that your left end is at the 4 because it doesn't quite make 5. Then you can look on the right of the 0 and see how many inches that you have. Because the scale is already broken up in 12 small lines, you'll notice that there's 11 small hash marks that are being used up. So you can either notice that it's one shy of being 12 hash marks, or you can count from the 0 and notice that there's 11 small hash marks, making this 4 feet, 11 inches. Now, the previous 2 problems were very straightforward because we have an architectural scale, but you may be put in a position where you don't have an architectural scale and you'll still need to determine how long something is on an architect's plans. If you're put in this position, for instance, problem 3 says we have a scale of 1/4 inch and we have to figure out how much 3 inches represents. Well, keep in mind that each 1/4 inch is 1 linear foot. So your job is to figure out how much 1/4 inches are in 3 inches, and that will tell you how many linear feet you have. Now, mathematically, you could take 3 inches and divide it by 1/4 inch. So you take 3 and multiply it by the reciprocal of 1/4. So you multiply it by 4 over 1. This gives you 12 linear feet. Another way to think about this is to realize that there are 4 1/4 inches in a full inch. So if there's 4 in 1 inch, there would be 4, 8, 12 in 3 inches. 4, 8, 12 linear feet. On example 4, at the bottom of page 8, they're giving you a 1/2 inch scale. We're asking how many 1/2 inches will go into 1 1/8 inches. Now, if we're actually going to do the math behind this, we're going to take our 1 1/8 and we're going to convert it to a mixed number. So we would take the 8 times 1 because we have 8/8, and we're going to add it to the 1 on top. So we actually have 9/8. That's 1 whole inch, 8/8, and 1 more eighth than that. So we have 9/8. We are dividing that by 1/2. Again, we would take the bottom fraction, flip it upside down, and multiply it to the first fraction. What we get is 18/8. As you can see with 18 and 8, they are both even numbers, So we're going to divide the top and bottom by 2. So we get 9 over 4. 4 goes into 9 2 whole times. Then we have 1/4 left over. So our answer is 2 feet, 3 inches. Thank you for joining us on this math review. I would encourage you to go back and read the material and then review the lecture again. I think it could deepen your understanding of the mathematics, and maybe you can catch some things that maybe went too fast. Thank you for joining us.